Alright, time for underdraftphysics.com. Debatephysics.com also. But so few people willing to engage in conversation. Yeah, conversation's tough. Sometimes you have to disagree and it's unpleasant. But I think grown-ups should be able to handle it and get over any kind of loose rhetoric. You might inadvertently offend each other by being a little pretentious or arrogant and blah, 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 blah. But, frankly, there's a subject to argue and you should be able to argue it, right? I mean, we could all be looking at a picture of Bigfoot, for example, and we could all discuss it and talk about, well, I can see the zipper. I suppose that should be the end of the conversation, right? As soon as you can find the zipper in the gorilla suit, kind of non-starter, right? We're all done discussing Bigfoot. So I could argue that there are some facts about the double slit experiment that sort of end debate, but, it's not as obvious as a zipper, so yeah. So maybe, we can still find room to, have some sort of conversation about exactly what does take place. So anyway, I found 4 channels that are interesting, and we'll see if these 4 different perspectives can engage with each other in some way and actually use what each other has observed and see if they can come to some sort of useful interaction in terms of applying what the different observations provide as information and combining that into some kind of useful information. Now, I would say the thing that was the most interesting to me to start off was this Hamdani Youssef. And I assume he doesn't do English very well, and so his video has a automated voiceover. But it's quite interesting. So this is something that Brozo messed a little bit with. And it's the idea of using a longer surface. So you're doing the double slit or the single slit. And instead of going by a little tiny razor blade edge, you're going by a longer surface and seeing what kind of pattern change you get. He has created an interesting pattern with just a single card impediment. So he's put a thin object long, and it's got a little tiny bit of a double slit kind of effect here, which is interesting. And then in the other version where it's a single slit just very long, it's regular single slit pattern. So that is interesting. It's still just 4 points, but then the argument is that yes, in this case there's nothing to block the light from going in these directions, where obviously in this case there is. So that's an interesting observation and does create an implication that I think does create insight into the function of the pattern. Now the other person is this guy. So Todd Grinsby. I'll leave links to these 4 channels in the description. What he has observed is a straight line effect. That a single surface will create this straight line. Now the interesting thing about a single surface is you could argue it has 2 corners. So it might be a single surface, but it still has a corner, a first corner, and then a second corner. Yes, it's only a few nanometers, a few hundred nanometers of thickness maybe, but it's still a corner. And I think that's a very interesting fact. Now I had said in a previous video that you can't create this. Okay, so essentially I said you can't create it as a 2 sources, couldn't do this, and without 2 sources you can't create this line. And then I took my high-powered laser, this green monkstery thing, okay, which will blind you, frankly. I don't like messing with it, frankly, because I can tell it's not doing my eyes any good. And so I do have glasses. I gotta wear them. I'm just I don't need no stinking glasses. I'm not much to, do what I'm supposed to do. But yeah, it's a really powerful laser. You can see the beam you can go outside on a damp morning and you can see the beam go for, dozens of yards, if not hundreds. Anyway, so it does produce a lot of photons. And so I did the green laser with a straight edge, and I did get the line. It seems very sensitive in terms of how much energy is actually hitting the edge, which I found interesting, and which I found is a sort of a little bit of an inconsistency with what he's saying. But who knows? I could point out little particulars. When he has these two pictures, you can't quite see this, but there's a little dot of the laser beam on the edge of the the razor. There's a little dot of the laser on the edge of this razor. So it really seems like the laser beam has been pushed over a little extra. That when you crank this down to a single slit, that you have to move the laser. And so I don't know whether he did do that in creating these images. I just don't know if these are, demonstration images or whether these are actual. The other part is he says he darkened the razor blade, but you can clearly see a very clear, bright edge on the laser beam. On the edge of the razor, which makes you wonder also. You do get a lot of reflection. Now, what I also tried was a round surface. And round surfaces will only create the line in one direction, that way. It won't create the line going this way. So that's, I think, an important detail in terms of recognizing that the round surface doesn't have two edges, doesn't have two corners. So in some respects, it's not capable of producing the fringe pattern. Or a fringe pattern in both directions. So all it has is the round surface, which again creates another phenomenon. You could argue that this is all about electrons, and I guess that's sort of what I will throw into the mix, is my argument that this is entirely a phenomenon created by electrons. The photons are hitting electrons, the electrons are moving, the movement of the electrons, the change in the direction of the electrons creates new photonic energy in a new direction, and that's what's creating this entire phenomenon. But anyway, everything, electrons are constantly pushing in and out. They're constantly moving, vibrating, and every time they do, they push, okay, on the field in the universe, right? The energy in the universe, they push on it. They push out and then they push back. That's essentially creating a frequency. And so every time their direction is changed, it changes the direction that they're pushing the force. They're reflecting it. So you can understand that if I sent a frequency in and I moved a hand forward while the frequency would come in, that it's going to get contracted, and that every time I go backwards, I would expand the frequency. So that's not too hard to understand. Anyway, so the third channel is the guy I talked to before, Debate Science, I think. I guess I could find his channel. It's his screen name is abbreviated when he leaves a comment, so it ends up being just SciDeb. Well, that's what it says as the channel name now. I thought it said Debate Science Debate or something, and so I guess he's changed that. I guess. So anyway, he just has the one video, and what he's done is let's watch the photons as they travel through space. Now the problem is you can't really watch the photons that are going to the target. The only ones you can watch are the ones that are getting stopped and are reflecting to your eye. So all of those photons in that image, they never got to the target. So they're really not photons that are doing the whole thing, okay? And in a sense, they're going to show you what they would do at a closer location. And the closer location is just showing you what has already happened to the photon, frankly. And so it completely lines up with either theory. Particles it's consistent with, it's also consistent with waves. So it doesn't really add much insight. I suppose the the fact that they should move on a little bit of a parabola is a mathematical fact. So in both cases it does look like it's a little parabolapic. You know, I would argue that particles would be more likely to be straight lines. But again, we do know that the fringe pattern does get bigger. The little dots get bigger as they go further out. So, you know, I'm not enough of a mathematician to say that that would result in a parabolic trajectory. But it might not be enough of a one to view without doing a great deal of distance anyway. So I'm not sure on that subject. But anyway. All right. And so the other video channel is this one. Yeah, that I will play some of this video. It's called TWTWW. And it's arguing for some time warp thing. So it's basically saying this multi-dimensional crapola, frankly. But it's got a good intro to the phenomenon. Now it's saying it's a simple explanation to create 15 time dimensions. I don't think that's at all a simple explanation. So, frankly, you know, some theories are just going to be out of the question for me. You know, if somebody looks at the Sasquatch picture and says, yeah, sure, it's in a suit, but it's a gremlin inside a gorilla suit. Yeah, I'm probably not going to go for that. You know, I don't think it's a gremlin inside a gorilla suit. You know, you're going to have to really show me some sort of evidence, like it's got big green feet or something. You're going to have something to explain how the gremlin is in the gorilla suit. Because I'm just not going to say that's the greatest answer I've ever heard. That's not going to be a great answer. All right, anyway. So, yeah, so I don't know if I need to. Let me just draw some of the stuff, and then I'll just throw in my bit to these people. They can ignore it if they wish, pay attention, whatever. Some of this stuff, like I said, I think, you know, now we can say decisively that this is a phenomenon created by the surfaces. It seems all these people seem to understand that surfaces are a function. Now, the one guy, I have to say, the Todd guy, I guess he doesn't think so, because he thinks this Huygens thing happens. He thinks photons go through the middle of the slit and they somehow create a vector going somewhere, like they get deflected because they're getting compressed or something, because somehow the photon can't fit through the slit, which is frankly ridiculous. Sorry, it's ridiculous, in my opinion. All right. So as I've pointed out, we have two kinds of patterns, so maybe everybody can agree on the two kinds of patterns. The distinctively different double slit from the single slit. And the distinctive difference is really just about this node size stuff and the envelope. The single slit is what traditionally ends up being an envelope pattern for the double slit. And double slit creates little nodes inside. So by doing the card thing, the one guy has gotten the single slit to essentially do something like this, right, which is interesting, right? Half and half. It's like a bastard of the two patterns, but let's take those out for now. Now, all four of these people, they should probably first attempt to explain this double maxima, because that's a real problem, okay? Water waves don't do that, okay? So water waves create this pattern, so all the same size nodes, so not the same pattern. And it's it's right in your face kind of statement saying, look, there's something to be explained here. You can't just ignore that and say, oh, it's an interference pattern. Here, I'll do a drawing of it. And the drawing won't produce this. So if you draw it out, you draw your two waves, you have to show how your two waves create a double maxima. So two waves, if I draw out all these waves, They're not going to do this. So that needs to be explained. So anyway, I'm making the simple argument that what's made easy to understand is if I take the single slit, all right, and I have a distance between these two surfaces, it predicts how many wavelengths are right in here, and that's what I end up here and here. So if I double this number, I'll get the total number of nodes that would be possible. And I suppose we all should agree that this pattern should be viewed on a circular surface where the distances are all the same, because then you'll get an accurate view of exactly what the photons are doing. And if you do that, the pattern as stated, these nodes get bigger and they get smaller and smaller and smaller as they come up. But the fact is that what you can actually do is calculate this number, and it will tell you, okay, what number you're going to have for how many possible locations can have the wavelength of difference. That is, you're using this as the base of your triangle, and you're basically just saying how many times can I get a wavelength of difference in one line to the other line, and it's all decided by this distance. All right, so that's the first thing to recognize, is that even the traditional math acknowledges that this and this are the two surfaces. There aren't, in the single slit, for example, the Huygens theory doesn't make any sense because there's not two waves here. There's not a point source here and a point source here. That won't work. Okay, so clearly the distance from the centers are here and here. So they can't draw it one way and then do the math a different way, right? If your math says this is the distance, then you have to draw your two waves here and your other wave here. Okay, and obviously that's not going to be easy to explain. It certainly isn't going to be easier to draw, okay, as why there would be a wave there, unless the fact is the surface is causing it. Okay, so this isn't about contracting light or doing any of this other stuff. It's about light interacting with a surface. All right, and the fact is the single impediment creates this same pattern, except there's less light going to the center. Okay. And it's really just about the same distance. So you're really just talking about a surface and a surface. So the single slit and the single impediment could fairly be described as the two surface experiment. And the double slit, all right, so the double slit could be fairly described. Let me draw it this way, and then we'll draw it, where we're going to bring those two together. So what you have are two single slits. And what you're going to do is bring them together. Now, obviously, when there are two single slits, this is the only distance you have, is this little distance. And that's why you get a smaller pattern, so to speak. And what you're really going to do is you're going to bring this over here and create, again, a small distance. But the key thing what's going to happen is when you bring this one in, you're going to create a very large distance. Okay, so now you have this distance. You have this distance, you have this distance, and you have this distance, right? And so these are all going to be comparably short distances, and they, I claim, the smallest distance will create the envelope pattern for the double slit. So the smallest distance between two surfaces will decide exactly how many of these nodes you have in terms of the envelope pattern. And the largest distance between two surfaces, which is always going to be this outside distance, that's creating the little nodes. And it works out mathematically just perfectly. And so you're basically just saying, yes, these are just point sources. The surfaces are flashlights. You turn them on. When you hit them with photons, you're turning on two little new flashlights that are producing the elements of a photon, the pieces. And the frank truth is all you're doing is got a 50-50 chance that when they hit the surface, they're going to be going in phase, or they're going to be going out of phase, or they're going to be going in phase, or they're going to be going out of phase. So that's all you're really saying. You've got a certain number of wavelengths that's telling you how many triangles you can make with a hypotenuse that is a wavelength longer. And so it's telling you exactly how many of these nodes you could make. And the real key is the center line. Because you have two slits separated by a distance, you really have two patterns. You have one going where lines are both going this way, and you have a pattern being created by lines going this way, both going in the same direction, you see. And so you really have two patterns, and that's why you have a double maxima. It's because you're overlapping two patterns. And this is the real giveaway, that you can change this starting point because these two lines are parallel, right? The line from this surface and the line from this surface go to this point, and this point can be a full wavelength of difference, a half wavelength of difference. It could be any part of a node. So it could be a dark spot, a dark, or it could be a bright. And obviously these all have to be proportional and lined up. So you can understand that this center maxima could be, from this contribution, something that's heading on or something that's heading off. And that's why this central maxima could be a little bigger or a little smaller, but it's always going to be two, because you're really saying it's made out of two nodes. It's two nodes worth of light. So that's why the two pattern, that's why there's a double maxima, because it's really two patterns. One created going this way, one created the light going that way, that are overlapping, that are being pushed close enough to each other to overlap each other. Alright, that's probably enough of the basics of what I would argue are key and important facts. So I guess I'll integrate that into what Youssef, is that his name? Sorry. That was his last name, I think. But anyway, pointed out. And so that's the corner thing. So I said this years ago, and I sort of haven't played with it much. But you could sort of understand how charge works, that charge gets funny around edges, corners. So what basically happens is you can have a very even charge field, and then at corners, the charge has to do this, it has to bulge. And then it goes back to being straight again. You end up with a bulge here too. So any kind of corner or point that you create in a charged environment, it creates a higher charge at that location. So it's the same thing kind of happens with spark gaps and stuff. The spark always goes to these little points. Any place that comes to a point becomes very interesting for electricity. Is because of this phenomenon with electrons. They can't really do corners. They can't just line up on the edge, here's the corner, and they can just line up, here's an electron and here's an electron. There has to be this odd guy out electron. And so, because it's going to be more pressure here, at this intersection, there's going to be more pressure, and so the electrons are going to stick out further going around the corner. All right. And so that provides a very interesting truth that maybe it is just the corner electrons. So maybe it's just the electrons around the corner of the impediment that are in fact hitting the light's hitting. And those electrons, because they're in different positions, will in fact be oscillating a little bit at different angles, which means they're still going in and out, okay? But they're also turning a little bit this way and turning a little bit that way, which could explain why the beam spreads a little bit up. Okay. Yeah, so in the long surface experiment, what's happening is that, yes, with the single card, okay, that the two corners, this front edge, okay, and then this next edge are both have electrons on them. And so what happens is that the photon is creating two sources. One source shoots out and this other source shoots out, and there can be any number of phase changes, but the fact is it's a 50-50 thing again. It's going to be a 50-50 chance that these two are in phase or out of phase. when they hit the target. So this one will hit the same place, this one hits the same place, and even though this is hundreds of millimeters, the fact is they're still either in phase or out of phase when they hit the target. So these are your two sources, the front edge, the back edge, and that's creating your pattern. And then when you do it through this thing, okay, obviously this first corner has no hope of going this way. So it can't create any pattern this way, and this corner can't create any pattern this way. It's blocked. So it can't make any contributions. And the only other surface that can make a contribution is this next surface. And so you get a different pattern because it's really, you can't shoot the light like the card can. You can't go in both directions. And so this becomes more traditional, and this becomes, yeah, something different. So this is the one that creates perhaps the double slit pattern within the double node, and then single slit pattern. So anyway, quite interesting. And obviously I'd argue it's all just particles. Particles at a frequency, that's what photons are. There's no imaginary fields. There's just momentum in the universe. There's just bumping particles, bumping bits of momentum. And you can have the material bits that don't move the speed of light, and you have the less material bits that do move the speed of light. All the motion is in the force, and the force just sticks to the electrons and protons and gives them momentum. I think it's a very simple explanation. Alright, so I think that's enough of that. So we'll play some of this other video just because it's an interesting introduction to the subject, and I thought worthy of some comment in terms of it provides a good opportunity for me to just say, yeah, isn't that silly? Yeah, isn't that silly? Why are people believing that crap?
Hi, welcome to the 9th video in the series where we will try to comprehensively...
Okay, I'll turn that down. Turn the volume up and turn that speed down a little. And such.
demystify the double slit experiments. Let's quickly walk through some of the experiments and effects that are considered unintuitive.
Okay, so the thing I didn't even talk about is the experiment where you actually do this with radio waves. Okay, so you just create two sources and then you put an antenna in the middle. Alright, and you can get the same pattern. That is, you can turn the antenna sideways and you could know that, yes, I can create out of phase, in phase, out of phase, in phase, out of phase. So if I move through this pattern at this angle, I can create a perfect single slit pattern. Okay, so, and the two waves will never even see each other. There's no argument that they interfered in space. They can't interfere until they hit the target. And obviously I could just move the antenna back and forth between these two, and I'll also create a point where they're jamming each other, and then they're not jamming, and then they're jamming, and they're not jamming. Same, but it's going to be the same exact pattern, except it will be missing, I believe, the double slit. It will be missing the double maxima. Okay. But it does demonstrate, the radio experiments do demonstrate that these waves don't do any interfering in space. That anything that happens to these photons, they don't know it happened until they get to the surface. All the action happens at the surface.
Wave particle duality first. When you send lots of particles through a double slit, they interfere with each other and behave like...
So again, this is a double slit, and it's really just a two-wave pattern, right? So we could call this, right, the two-surface experiment. And the key point is that these are really tiny slits, so the point sources are very close to each other. So actually, all you'll get is a single slit pattern out of a very small double slit. So if you make the double slit very thin, you've taken two of the point sources and made them so close together that they can't create any wavelength of difference. The bottom of the triangle is so small that there is no line that can be drawn from those points that will have a wavelength of difference between the hypotenuse and the side. So they can't produce interference and they can't produce a fringe because they can't create a wavelength of difference. So you end up with a single slit pattern. So that's kind of the joke. They call this the double slit, but they make the distance between two of the surfaces so narrow that all they create is a single slit pattern.
Like a wave, but particles are countable entities. When observed, they're in one place. Single particle interference.
So it really should be understood that there are two distinctly different patterns. The full double slit, that is with open slits, is a completely different pattern. I mean, it's, you know, it substantially has its own details that are really important. The fact that it basically has two patterns built into it, and so they shouldn't mush the two together and say wave interference or fringe pattern. Say these words without detailing whether it's a fringe pattern that is got the double maxima and nodes, or the one that actually has nodes inside of the double maxima. Very different patterns.
When you send the particles individually through a double slit, one...
Alright, so we know this individual thing never happened. So what they do is they put smoked glass to dull the number of whole photons that are going through the slits. So what they're really doing is just breaking the photons. The smoked glass is just a bunch of particles in the glass. It's just a bunch of slit experiments. They're just putting a bunch of corners in the way of the photons, breaking them into little pieces, and then shooting the little pieces at the double slit. So it doesn't make any difference. The double slit doesn't care whether you hit it with whole photons or broken photons. It just cares that you're hitting it with bits that make a photon. And so it's just, you're just saying I can break the photon before it gets to the slits, or I can break the photon at the slits. It really doesn't matter, because all I'm doing is remaking them at the surface. So clearly it's not a single photon experiment. They don't shoot single photons, they don't shoot single electrons. It's completely a deception, basically a lie. They don't really do what they claim they do.
After the other, they still eventually produce an interference pattern. So what does each particle interfere with? A single particle.
Yes, it's interfering with other broken pieces, because you put the light through a bunch of obstacles and you broke it into little tiny pieces, and then you just reconstruct it again using the slits as a reconstructor, as a phase fixer.
Can't go through both slits at the same time, can it? Detectors at the slits. If we use...
So we know detectors at the slits is another... This is just a real lie. I mean, it's a huge lie. I guess I could slow this down even more, because he does already talk fast. Alright, so we know detectors at the slit didn't happen. This is a fake experiment. There is no such thing as detectors at the slits. You can't, especially for photons, you can't detect a photon, and clearly if you hit an electron with any kind of energy, it moves. And they're charged. You can't even shoot a charged object through a slit and expect it not to be messed up by the charge forces. It's just ridiculous, frankly.
Detectors so we can see which slit the particle goes through. The interference patterns disappears.
Okay, so this is all nonsense. It isn't the truth. It never happened. They never detected, blah, blah, blah.
We get two peaks corresponding.
That didn't happen either. The two peaks would be less than a millimeter apart for a standard slit experiment. We're talking about an experiment that's less than a millimeter between the surfaces. Those two peaks at the target meters away, those two peaks would still just be one, half millimeter different. So they'd be right on top of each other. You wouldn't be able to tell one from the other. So again, it's more just distortion in how they show the experiment. It can't happen this way. It doesn't happen that way. It's just nonsense. And so he's repeating nonsense and saying, look at the nonsense. We have to explain the nonsense. No, you don't have to explain nonsense. So this just never happened. It's all fake, phony, and fraud.
Going to the detectors. It behaves like a classic particle going through one slit or the other. Well, not quite. In fact, it still gets diffracted, but each slit makes a single slit diffraction pattern.
Says you. So you just said it. You said it makes a dot, and then you said it makes a single slit pattern. Which one is it? I mean, just that. It's just so duplicitous. Oh, it makes a single slit. Well, then why are you drawing it as a dot? It should be a bunch of dots. Single slit pattern goes very wide, creates lots of fringes, creates a huge giant pattern. Doesn't create just a little lump. I mean, just, again, too ridiculous. Too ridiculous.
The nonsensical conclusion seems to be that a particle is just a probability that exhibits wave behavior.
Yeah, this is just whatever. Einstein's Feynman's probability theory crapola, okay, or their Copenhagen crapola, or their whatever crapola. And it's all just crapola. It's all just cheap, superficially flawed, trivially flawed explanations. Again, they're still drawing it as if they're drawing a double maxima. These drawings will not produce a double maxima in the center. So why do you keep drawing it a way that doesn't work? It won't do what you need it to do, which is to create the double maxima. So why you keep drawing it a way that doesn't work? I mean, it's a very good question. Why do you keep drawing it a way that it can't possibly be happening? Because that's not what it produces. It's a pattern. So this is so bad in so many ways, right? Okay. Well, anyway, let's continue.
Behavior like interference until detected when it pops into existence in a random but definite location.
Look, this popping into existence, that's not even Feynman's argument. Feynman's argument is just randomized in its change in direction by going through the slit. And it doesn't matter whether it goes through the middle of the slit or the edge of the slit. It doesn't matter where it goes. Somehow it just gets randomized. And we'll just calculate and we won't bother thinking about it. So obviously a silly, almost imbecilic surrender where he's just running away from his scientific obligation to come up with a better answer than that nonsense.
Quantum eraser. So maybe it's the act of
So the good news is he ignores this entirely and just says fuck it.
detecting the particle that makes it behave in the classical expected way. In the quantum eraser experiment, we place the detectors and then destroy the information they collect. The interference pattern is back, sort of, but the details of the experiments matter. It turns out
it's a big pile of horse shit, frankly. So it turns out they're using two sets of slits. They're putting the light through a crystal, creating two different photons, then putting those different photons through different slits. The whole thing is a big pile of crap.
that the quantum eraser experiment and its relatives, the delayed choice quantum eraser, are not that illuminating. I started making animations, but it turns out if you understand the standard double slit experiment, then you pretty much get understanding of the quantum eraser for free. In the interest of brevity, I've removed that section from this video.
Thank you.
Sabine Hossenfelder has a good video on the quantum eraser. Instead, I added a section on the bomb experiment. Many YouTube videos present the counterintuitive nature of the double slit experiments in much more detail than this super brief
I don't know what the bomb experiment is, but I don't even want to know, frankly.
overview. Here is Don Lincoln at Fermilab expressing a somewhat fatalistic sentiment.
Fun fact, I went into physics hoping to solve this quantum conundrum, but as I got into it, I saw just how hard it was. If a century of smart people thinking about it hasn't solved the problem, I probably wasn't going to either.
All right, so again, more surrender. It really isn't that complicated, right? You have a distance, you have this phenomenon of vectors and phase, and really all you have to do is get the diagram of the photon right. So you don't even have a diagram of the photon. You got some silly snake that somehow knows how to snake through whatever. How is it snaking? What exactly is telling it how to snake? And do you really think a photon billions of light years, or let's just say great deals of distance from any other physical object, and it's flying through a bunch of empty space, that there's some sort of field that's the entire field is vibrating for billions of light years of distance to cause it to snake? I mean, come on, it's just absolutely ridiculous.
So I went to particle physics, which was equally interesting and a field where I could make.
Yes, you could do stuff because it's all make-believe. You just make-believe. It's all make-believe. MV squared, fake, phony particles. 400 fake, phony, nonsense particles. Antimatter. What a pile of mush.
Make a difference, and, well, the rest is history.
There is no history. You didn't invent anything. You didn't do anything. You just tell us a story about the magical particle you created that lasted 1/100th of a billionth of a second. Look, it's an imaginary fake thing that lasts a billionth of a second. See? Oh, wait a minute. You can't see anything. Yeah, that's right, because it's all theoretical shit. Ugh, amazing. Can't pave a road with it, Can't pick your nose with it. Can't do a damn thing with a Higgs boson. Ugh.
Even though the double slit experiment is mind-blowing, there's more to the story.
Jeroen from Huygens Optics is an...
Yeah, Huygens Optics, another wave guy who won't interact with anybody, so you can't make any counter argument to a damn thing he says. He's just a preacher doing his preaching. Unfortunately, there's just way too much of that in science. All these people pretending they care about the truth in science and finding the truth, and they're completely incapable of reasonably responding to any kind of critique or criticism. They just run away and call you a name. So, big fat pussy.
amateur and original thinker interested in the nature of light.
Original thinker, closed-minded, cement-headed shit talker.
Unlike armchair scientists like me, he has a lab with lasers and...
Yeah, he has all of that shit, and he just uses it to propagandize for what he's trying to prove, rather than accept that his results show a little bit of a mushy ground, and it's not so decisive, and all of that. So he just, again, emphasizes whatever's for him, and he completely kind of just pushes under the rug anything that doesn't look too good.
Actually does the experiments. In general, the attitude is that quantum physics is just counterintuitive and weird, and we just have to deal with it because that's the way the world works.
Well, it's not just counterintuitive and weird, it's fucking stupid. And sorry, what you're going to say is just fucking stupid. This isn't where you look first. It's a gremlin theory. I mean, time dimensions, really. I might as well, you're just talking multiverses. I mean, this is just such bullshit. It's a three-dimensional physical universe. There's crap in it right now in all kinds of locations, and it's really doing the same shit we are. It's just doing it very far away, and that's it. And if any information gets to us, it only can get to us at the speed of light, so we're really slow in finding out what's going on in the universe. But, frankly, it's just silly to think that there's an imaginary fake universe over there, and there's another universe over there, and there's all this other crap going on that's changing what everything does. We have enough reasons right here. We can find the bullet, right? No one's been shot with one of these bullets from another universe. It's just too silly.
Here is Jim Al-Khalili at the end of an introductory lecture.
Yeah, another bullshit scientist just talking absolute crap. Might as well just be a religion, because he just makes up all these fake stories about these experiments that have never been done, and certainly never done the way he shows them. Never happened this way. This never took place. They never shot electrons through two slits and got this really good pattern. That never happened. And when they did try to do it inside of an electron microscope, which doesn't shoot random electrons, okay, so you can't even get them to go through the two slits because they are not random. They go exactly where you shoot them. They go exactly where you produce an electrical potential. You can't shoot them at two slits randomly.
On the double slit.
Now, if you can explain this using common sense and logic.
Why would I try to explain a fake, phony, completely fake circumstance that you detailed as a truth? It's not even a fake photo of a Sasquatch. He's just describing, I saw this big lumpy thing, and it was this translucent blob-like material. Can you explain the existence of it? I don't think I need to, because I don't think it exists, and I think you just made all that crap up. So show me the electron gun, show me your slits, show me your results. Show me that this was what you did. Even the pattern isn't created by hitting something with the You know what they do? They hit a surface with the electrons, and then they create photons, and they see the photons. They can't even see the electrons' impact. They have to convert the electron into photons.
Do let me know.
We aimed
Pompous, douchebag, arrogant, shit-talking, ivory-towered crap. And people suck it up. Oh, please, King, tell me about reality. Tell me how your blue blood is better than our blood. You know, tell us any kind of crap you want to tell us, because we're all just going to be little servants to douchebag, arrogant, you know, mathematicians.
To do exactly this. Explain it using common sense and logic.
So I'm afraid he's not going to do that. So I'll just play a little bit where he just, right from the beginning, you just say, oh, come on. This is your best effort at coming up with something simple and reasonable?
If this is possible, why has that not been done already? Well, it does require some mental agility because we're working with 3 time dimensions, which...
3 time dimensions? What do you mean, 3 time dimensions? What are you talking about? Dimensions are... There's a rule for a dimension. It's called the right angle, okay? All 3 dimensions have something in common. It's all right angles to each other. There's just no more room for any frickin' more dimensions. You can't fit any in there and get right angles. So you're all done with the word dimension. Time isn't a dimension, it's a function. Okay, and it's a function that the fact is there is a speed of light. The fact is there's a speed of motion in the universe. Things don't move instantaneously. Okay, they can't just leap to another location in space. They have to travel there, and there's a limit to how fast anything can travel anywhere, and that's the force bits, obviously, are moving the speed of light, and gravity and light and electricity and magnetism all traveling the same exact speed, which gives you an indication they must be all the same shit, of course. But no, you can't even draw that simple conclusion. But what, 3 time dimensions? Ugh, there's 1 time function. There are not 3. The time can't be a dimension. It's linear.
It does take some getting used to. If it was really obvious, somebody else would have worked this out 100.
No, I mean, whatever. You can't, nobody figured out that they never proved 1/2 mv squared. They never proved that what's conserved in the universe is kinetic energy, you know, mv squared. They never proved that. And nobody for 300 years could say, whoa, you're making a mistake. Don't do that. That's really dumb. Don't believe in something nonsensical. Newton said momentum is conserved. Why are you dissing Newton? He kind of got a lot of right answers. Why are you fucking with that? You can't, and you haven't even figured that out. You haven't even figured out that it doesn't make any sense to say it takes 100 times the energy to spin a motor 10 times faster. You haven't figured out that that's probably bullshit. All right, so no offense. So, like I said, I love the beginning of the video. The rest of it is a bunch of wooey, made up, blah, 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 blah. Yeah, I have to watch some. I haven't watched all of it, frankly. Oh, there's the bomb experiment. Maybe we'll watch a little of the bomb experiment.
In multiple time dimensions, you can rig up an apparatus that uses interference with neighboring timelines to check if the bomb has exploded.
All right, forget it. Okay, forget it. No, it's not a real experiment. It's some sort of thought experiment about multiple time dimensions, and you have multiple time cameras, and oh, you know, come on. Oh, please. Shit. Anyway, it's just disappointing that that's the best he can do with a simple, rational explanation, is to propose multiple time dimensions. Shit. All right, so 4 channels, and it would be nice if people could interact. You know, if we can interact constructively and talk about the physics and such. I think that would be good, but we'll see if that's possible and such. So we'll call that a video. Really, if I've offended you, sorry. I didn't mean to offend you. It's my honest opinions, okay? I gave you my honest opinions. You can have an honest opinion about what I've said, yeah. If you think something I said isn't true and it's nonsense, you can point it out. It's okay with me. But you can't be dishonest about it, right? You can't just say, hey, that's garbage. You have to do a little better than that. All right, so anyway, till the next time and such.